In today's video, we are going to continue on with that idea of the number of ways we can arrange certain items. And we're going to talk about two important new concepts today. We're going to talk about the fundamental counting principle, and we're going to talk about what's called a permutation. So again, you do want your calculators out, and I did post a document in Schoology that describes how you can type in the permutations into your calculator, or I did also give you a website in which you can access a permutation calculator as well. So let's look at the fundamental counting principle. We kind of used this in our last video when we looked at the number of ways we could arrange n items. So if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. So my advice to you for these problems that we're going to do today is I would write out the spots and the spaces the same way we did with that arrangement of different items like we did in the last video. So number one, how many different outfits can be made from 10 shirts and 12 pairs of pants? Well, we're talking about two events here. We have shirts and pants. All right, so if you think about it, I have shirts and I have pants. Well, I have 10 shirts to choose from, and I have 12 pairs of pants to choose from. So the number of outfits that I can make from shirts and pants is 10 times 12. So one thing we want to remember is that when we're talking about and, that means to multiply. Okay, that's going to come up later in our probability unit as well. So 10 times 12 is 120. So there are 120 possible outfits that you can make from 10 shirts and 12 pants. Okay. Let's look at number two. There's 4 roads that you can drive to get from your house to your friend's house. If you don't want to take the same road home, how many different ways can you drive to your friend's house and back? So you're going to go to your friend's house and you're going to come back. So if you think about it, we're going to and from. Well, there's 4 roads that you can drive to get to your friend's house. So on the way to your friend's house, you have 4 roads. Now you might want to start thinking about what might change based on the description of the problem. So in this situation, you don't want to take the same road home. So how many roads do you have to go for the on the way home? Well, you can't use one of the ones that you drove to her house or his house. So if there's 4 roads too, then you only have 3 options to come home, right? Because you can't use the same road that you used when you went to their house. So the number of ways to go to and from your friend's house is 4 times 3, which is 12. So there's 12 ways you could go back and forth without going on the same road home. Okay. I can extend the fundamental counting principle to contain more than just 2 events. So it could be 3 or more events. All right, so let's say you have 3 events and they occur in m, n, and p ways, then the number of ways that all 3 could occur is m times n times p. I could extend this for 10 events, 12 events, whatever. What I would encourage you guys to do is just to keep listing out your spaces, labeling your spaces so that you know what to substitute in, and then just multiply those numbers at the end. So the standard configuration for a PA license plate is 3 letters followed by 4 numbers. So I want to know how many license plates are possible if you can have numbers that are repeated and numbers and letters that are not repeated. So one thing you want to remember, hopefully remember this, is that when you're talking about making a code or a combination or a license plate that consists of numbers and letters, there's 26 letters to choose from, right? A through Z. And think about the digits that you're going to pick. There's 10 digits that I could fill in slots with, and they are made up from the numbers 0 through 9, right? You don't have a number 10. That number 10 is made up of the digits 1 and 0. So to make our license plate, we can either have 26 letters to choose from, or we can have 10 digits to choose from. 0 through 9, there's 10 numbers in there that we can pick. So a PA license plate is 3 letters. Okay, so there's the letters. All right, followed by 4 numbers. Okay, so these are numbers. All right, so the important thing in this one is that we can repeat letters and numbers. So how many letters do I have to pick from to put in my first slot? Well, there's 26 letters. I'm allowed to repeat, so I also have 26 letters to go in the second slot, and I also have 26 letters to go in the third slot. All right. Possible numbers. Well, there's 10 digits to choose from. I'm allowed to repeat. So there's 10 digits that could go in the first slot. There's 10 that could go in the second, 10 for the third, and 10 for the fourth. All right. The number of possible combinations of license plates made up of 3 letters and 4 numbers is the product of all of these possible combinations. So 26 times 26 times 26 times 10, 10, 10, 10. All right, and that gives us 175,760,000 different plates. So I'm going to put that in over here. Okay, so that's the number of license plates Pennsylvania can make from 3 letters and 4 numbers, but that's if you're allowed to repeat letters and numbers. So what do you think is going to happen if I change this to say that you can't repeat letters and numbers? Well, I'm still going to have 3 letters followed by 4 numbers. Okay, and in the first spot, just like before, I have 26 letters to choose from. But now if I can't repeat letters, you have to assume that that letter you already used, you can't use anymore. So for the next spot, don't you only have 25 letters to choose from? And then for this third spot, you have to assume you can't pick those 2 letters that were already used. So you really only have 24 letters to choose from, right? Same thing with the numbers. You've got 10 digits to choose from, 0 to 9. But then you have to remember that you already used a digit. So for this digit, you only have 9 to choose from. Then you've used 2 numbers. You can't use those 2 again, so you really only have 8. And then the last spot, you only have 7 numbers to choose from. So without repetition, we're going to have a smaller amount of values, of plates. Okay, so I'm going to type in 26 times 25 times 24 times 10 times 9 times 8 times 7. Right, and you can see that we get 78,624,000 plates. So smaller amount because we are not allowing repetition of numbers and letters. Okay, so just be careful if I'm talking about with repetition or not repetition. This should be the work that I see, and how do those numbers change in those slots based on repeating and not repeating values. So you want to use these examples for like locker combination codes, passwords, zip codes, anything like that where you're making a combination of letters and numbers. Okay. So this brings us to our second idea for this unit, which is what's called a permutation. All right. Well, we kind of already did a permutation. Okay, so like when I asked you to order n objects, right? Like in the last video, I said line up 4 pictures on a wall, or order the 10 songs on your phone into a playlist. We did n factorial, okay? But that's if we want to order all n objects. Maybe you have 8 pictures, but you only have room for like 6 pictures on the wall, right? And how many ways could you arrange only 6 of those 8 photos? So that's where we're going to use this permutation formula, or your calculator will also do it for you, or we can also do it just the way we've been doing on the front page, okay? In a permutation of n objects taken r at a time is an ordering of just r objects taken from a group of n. So here's your formula for permutation. NPR is equaling n factorial over n minus r factorial, where n is your total number of objects and r is the number of objects you want to arrange. Now this formula is here in case you need it, but we're going to use the calculator button to kind of do that for us, or you can just type these in kind of the way we did it on the front page here. So here's an example, all right? For number 4, there's 10 students in my Algebra 2 class. How many ways can I line up all 10 students in the front of the room? Well, that's all 10. So I'm ordering all n objects. So this is just like what we did in that last video. That's just 10 factorial. 10 factorial is 3, 6, 2, 8, 8, 0, 0. Okay? All right? Okay, but let's say part B, how many ways can I just line up 6 of the students at a time? All right, well, there's 2 ways that you could look at this, okay? You could say, well, I've only got space for 6 students. 1, 2, 3, 4, 5, 6. And I've got 10 students to choose from. So there's 10 kids I could put in that first spot. I've already used a kid, so now there's 9. Then there's 8, 7, 6, 5, right? There's 6 slots, 10 kids could go in the first one, 9 could go in the second, 8, and so on. If I multiply these together, I get 10 times 9 times 8 times 7 times 6 times 5. I get 15, 1, 200. Okay, so I get 151,200 different ways to line up 6 of the 10 students. Okay, so one way you could do is you could just write the slots out, the spaces, fill them in just like we've been doing. Or you could use this permutation formula, right? If you think about it, NPR, okay, N is the total number in the group, so there's 10 students in the group. I want to arrange 6 of them, so 10p6. So in your calculator, what you would do is you would type in the number in the group first, so 10. I would go to the math key and scroll over to PRB, or the probability menu, and option 2 says NPR. So I'm going to select NPR, and I'm going to type in 6. So this is saying take 10, arrange 6 of them, and I get the same value I got over here. 151, 200. Okay, so you can use the formula or you can write the slots out. It really doesn't matter. Some people like visualizing everything. Other people like to kind of just use the formula. Okay. All right, number 5. There's 12 students racing in the 100-meter dash. In how many ways can first, second, and third place be awarded? So, if I were doing this problem, I think it'd be easier to actually say, well, there's 3 spaces I have. I have first place, I have second place, and I have third place. How many kids are racing? There's 12 total kids racing. So I've got 12 kids that I could possibly give out a first place award to. Okay, that kid won first, and there's only 11 kids left for second, and then there's 10 kids left to get third place. The number of ways to give out these 3 places is 12 times 11 times 10, which is 1320. Okay, or if you want to use the formula, okay, our formula is NPR. So I have 12 total students, and I want to arrange 3 of them because I'm giving out 3 places. So if you typed in 12, math, option 2, NPR, R is 3, I would also get 1320. Right? So it depends on whether you want to visualize everything or you just want to type into a formula. All right. Last example. From a club of 24 members, a president, vice president, secretary, and treasurer are being elected. In how many ways can we fill these offices? So again, I like to do the spaces because I like visualizing everything. I have a president, I have a vice president, I have a secretary, and I have a treasurer. There's 24 people I could elect president. If one of those people is president, then I only have 23 people to put in as vice president, which means I only then have 22 for secretary, and I only have 21 for treasurer. So the number of ways these 4 spots could be filled, 24 times 23 times 22 times 21, which is 25, 5,024. Okay, 255,024 ways to arrange, or I should say to elect president, vice president, secretary, and treasurer. Or, okay, don't forget you have the formula. There's NPR. There's 24 total people. You kind of want to arrange, or you want to elect 4 people from that 24. So 24 math, PRB 4, 24P4 gives you that same value. Right? So it's up to you how you want to do those. The only thing you have to be careful about is if I'm talking about you know, repetition or not repetition, just make sure I would probably write the spaces out and really fill in what should go in those spots. But in terms of work for this section, you know, I'm kind of looking at basically the work I have on my notes. For some of the problems, you have to write the slots out. Maybe some of them you're just showing me what you typed in to the calculator. Or if your calculator does not have that option for permutation, then there is a website I posted in the document that will also take you to a permutation calculator.